We next go on to part B of this question, where this question is given a circuit as shown. Same circuit that was referred to in part A, but what do we need to determine this time is the power factor, the real power, the reactive power, and the apparent power. Subsection 2 asks us to connect an extra capacitor here so that the power factor can be improved to unity, and we are required to calculate the value of this capacitor that we want to add on to. Well, let's start. Well, to answer part B, we need to refer to some of the answers that we calculated earlier on in part A. That's where total impedance is given as 18.512 plus J 27.716 ohm, or in the phasor version as 33.33, so on. The input voltage phasor is given here, and the input, so-called the supply current phasor, is written as so. So for power factor, is actually the cosine of the phase angle difference, which is actually the angle given by the impedance here. So it's actually cos 56.26 degree. That gives us a value of 0.555 lagging. Right? Lagging, why? Lagging because the voltage is ahead of the current. Now the real power can be calculated based on the information given as the magnitude of E multiply the magnitude of the incoming current cosine of the phase angle difference. That gives me 325 divided by root 2 multiplied by 6.893 multiplied by 0.555. That gives me a value of 879.16 watts. Okay, that's the real power. The reactive power is the magnitude of E times the magnitude of I sine the phase angle difference. So it's 325 over root 2 multiplied by 6.893 multiplied by sine of the angle. Sine of the angle, in this case 56.26. Sine 56.26. 0.8312. That gives me a value of 1317.27 VA reactive power. And finally, the apparent power is just E multiplied by IS. That's 325 over root 2 times 6.893. That's equals to 1584.0. So if I were to draw the so-called power triangle, I will get we have something like this. The real power P or R, sorry, equals to, I should be showing this as P. I'm sorry, this should be P. And real power is 879.16. The current reactive power Q is 1317.27 VAR, and that's why the apparent power is here at the angle of 56.26 degrees. Right now, part 2 wants me to introduce a capacitance so that this will be cancelled. To improve the power factor to 1, I need to move this down. In other words, I must introduce a reactive power using a capacitor, because capacitor is negative of inductor, same amount. So that my power factor goes to 1.0. Right, but we know that QC is also E squared divided by XC. Therefore, from here I can determine XC is equals to E squared over QC. That's equals to E squared is 325 times 325 over root 2 times root 2. The whole thing divided by 1317.27. That gives me an XC of 40. But we know XC is also equals to 1 upon omega C. So from here, C is equals to 1 upon omega was omega we know from the question to be 314, right? So 314 times 40. So the capacitance required is 79.43 microfarad. Alright. So the key point is we need to introduce the reactive power Q such that this value will cancel this value. Alright, so that's it for question 2. I'll see you again next time.